Alright, welcome everybody. AP Calc, let's do this. So this was your Desmos intermediate value theorem homework. We're going to talk about the intermediate value theorem tomorrow. But what I'd like you to do is, just based on what we did today, here's the graph, and we have it covered by, as Frank would say, these bubbles, no, these circles of A, B, C, and D. And what I'd like you to do is answer the questions: where must there be roots, where may there be roots, and where must there not be roots, okay? And please give a proper justification. And if you just want to review the idea of what is a root very quickly, a root of a function is where the graph intersects the x-axis. So if I have some graph over here, notice that the graph intersects at A. It does intersect at B, it just bounces, but it still intersects it. And at C. So the roots are A, B, and C. Okay? What I want you to do is take your time and try and write a proper justification of all three of these. Okay? Alright, so let's say you are done with that, and let's check. Here, where must there be a root? Well, let's see. For A, well, one thing that's very important is the idea is that the function is continuous. Okay? We wouldn't be able to make these assumptions if the function wasn't continuous. But let's take a look. So this graph over here, it could have a root, it could go down, or it could just kind of just go like this and not hit this x-axis. So here, A is a maybe. So here, we'll put A over here as a maybe. B, well, let's take a look at B over here. You see here, it doesn't guarantee, there's no way there could be a root here, because notice that this line doesn't go under the x-axis. So B, this will be this cannot be a root at B. But where could there be a root? There could be a root at C and at D. So C and D. Now this part wasn't too bad, trying to figure out where there must, may, or not be roots. The difficult thing is the justification. So here, how can we properly justify, using algebraic notation, why there must be a root at C and D? And the idea is, visually, for what I'd like you to do is take a second and pause the video and write this down, okay? So let's say you pause the video and you wrote this down. Visually, for a continuous function to have a root, there must be a point above the x-axis and below the x-axis, okay? This is visually, and visually it's pretty easy to see that, like at C and D, there has to be a root, because you know it's continuous, so you don't know what's happening to the graph. Like, anything could be happening, but you know it has to go through it, okay? But algebraically, this is the thing, this is the connection we need to make. You have to understand that what this is saying, that if I have some point over here, and I have some point over here, notice that one of my points, this is positive. This means that one of the y values, like if I have an x, f of x, right? Or x comma y. Remember, don't get mixed up with f of x and y. F of x and y are the same thing. Here it's saying that, notice that one of my f of x values is positive. It's above, this is positive, and it's above the x-axis. Here, this is saying that one of my points over here, f of x2, that this point is negative and it's below the x-axis. So this is what we need when we have a proper justification. So what we could say is, notice one point is above the x-axis, and what we could say is, you see, that's visually. Notice one of the points is above the x-axis. Algebraically, our first point, f of x sub 1, the first point we have is greater than 0. This is saying that one of the graphs is positive. And then notice the other graph, f of x sub 2, is negative. So if you have one graph that, one point that is positive and one point that is negative, there has to be at least one root. There could be like a million roots over here. You never know, like the graph could go up and down like this. but we know that there has to be at least one. Okay, let's hopefully that feels okay and that should sink in. All right, let's do the next part over here. So for this, we'll have some fun with this one. Here, let's do number 4. It says, let's take our time. Here it says for the continuous function h of x. Okay, so we have continuity is given below. At least how many roots must exist? Okay, at least how many roots must exist for the function? Okay, so the hint was, if you weren't able to try and do it by yourself, what I want you to do is graph all these points, okay? Let's graph the points. So -3 and let's put it here. So this is 1, 2, 3, 1, 2, 3, 4, 5. Okay, so we'll put this point over here, and if you feel like you want to skip the video until I actually graph the points, because this is going to take me like a second or two. So -2, -2, -1 is here. Okay, -1, 3 is here. Okay, is this point here. 0, 5 is 4, 5 is here. 1, -2 is here. 2, -5 is here. And 2, 3, wait, 1, 2, 3, 4, oh, sorry, it should be here. And 3, 7 is 3, and then 7 over here. Okay, so then let's take a look at this. Oh, whoops, my bad. I am bugging out. 3, 7, that's not where 3, 7 is. 3, 7 is here. So 3, 1, 2, 3, 4, 5, 6, 7. Okay, so now that we have the points, right? Try and ignore these two with the x's. Now that we have the points, it states that the function is continuous. So what are you allowed to do with the points that we have? We're allowed to connect them. So let's see. We have here, here, and here. Oh, whoops, we forgot one. But it won't matter. Okay. Wow, I just really messed this up, but it's okay. The idea is, at least, how you see, you don't know that the graph looks like this, but you know it has to connect at least 3 times. It could, the graph, for all we know, could look like this. Then boom, up, like it could have an infinite amount of x-intercepts. But we know that it has to hit at least 3 times. And that's it. That's what we should have gotten for this. And the idea is, let's imagine you have no graph. Okay, so we have no graph. Okay, let's just look at the table. Okay, this is the deep level idea. How many times did the f of x values change sign? So change sign, does it go from positive, oh god, that's a nice word, positive to negative, or negative to positive? Okay, why don't you try and answer that question? Take your time. Right? Notice that it changed 3 times. Notice that it's negative, negative, right? And then this becomes positive, then it's positive, then it becomes negative, and then it's negative, then it becomes positive. Notice that the sign changed from negative to positive, or positive to negative. It changed 3 times. And that's exactly what the connection is with this, that it has to hit at least 3 times. Okay? What I want you to do is try and visualize, like we just did this over here, but try and visualize this by yourself. Ask yourself, is this point, take your time with this, right? Ask yourself, is this point above or below the x-axis? For example, like this, let's just imagine this is my x-axis. We don't even need the y-axis, it doesn't matter. Here, like, look at the first point. So this is the first, the second, the third, the fourth, the fifth, the sixth, the seventh. Look at the first point. The first point, are you above or below? Notice that we're below. Okay, let's look at the second point. Are you above or below? You're still below. Look at the third point. Now, because you're looking at the y value, now you're above. Now notice that if it goes from below to above, then it has to hit at least 1 time. okay? At least one. And then notice that it does that again. So let's see over here. Look at the fourth point. Where, if you look at 0, 5, are you above or below the x-axis? You're still above. Look at the fifth. Now, what happens from here to here? You're below. So then this has to happen. And then notice that now that we're below, if you look at 5, you're below. 6, you're below. And then 7, you go back up. And notice it has to hit 3 times. All right? What I'd like you to do is try and do the next question over here by yourself. But you see, now the idea with this is we're not looking, you see, what's the equation? Like, what's the equation of the x-axis? You see, this is y equals 0 is the x-axis. What if we don't just look at the x-axis for roots? What if we look for something else, okay? And I'll explain in the next video. But try and do it by yourself.